Okay, so we're going to take a look and do some kinetic energy and potential energy problems here. So we talked about these two different equations. Energy is the ability to do work, and then we talked about potential energy. That's the energy that is caused by a position. So as long as anything's above the ground, it has some type of potential energy. And then kinetic energy is the energy of movement. So as long as it's moving, it has kinetic. So I wrote these two equations. I also went ahead and put the units of these so that you can always know what you're working with. So this is kinetic energy. We know that energy is measured in joules right here. And then the equation is 1/2 mv squared. So mass is always measured in kilograms. And velocity is always measured in meter per second. So when you're doing a problem like this and you're not sure what to do, look at the units, and the units will tell you where to put things inside this equation. We also have the potential energy equation. So potential energy equals mgh right here. So that's mass times gravity times height. Again, energy, all types of energy, no matter what the type, is always represented by joules. Mass is kilograms. G is what we've been using here, 10 meters per second squared, and H is in meters. Okay, so we're going to look at those, go through these problems right here. So I'm going to look at this one first, the kinetic energy. So that tells me I'm going to use this first equation right here, and it says it has a mass of 3 kilograms and a velocity of 4 meters per second. So I know it's mass because it's kilograms, right? That's looking right here, and velocity meters per second. I can go ahead and solve for kinetic energy. So I'm going to go ahead and just set up my kinetic energy equation here. 1/2 mv squared. So kinetic energy right here. And then I'm going to go ahead and solve for it and plug these numbers in. So that's 1/2 times the mass. And my mass right here is 3. And then times my velocity squared. So that's 4 squared. So I'm going to go ahead and start with 4 squared. So that's 1/2 times 3. Then times 16, because 4 times 4 is 16. Okay, and another, this is multiplication, right? So the order doesn't matter. So instead of taking half of 3, I'm going to take half of 16. I think that's a little bit easier here, which is 8. And then I can do 8 times 3. So this is going to be 24. Now I left off my units. I need to make sure I include those at the end. So this is energy, right? Kinetic energy. We know that energy is in units of joules right here. So I'm just going to put joules right there. I'll move this down here, make it a little easier to see. So anytime we're doing these problems, right, we can set up our equations. We identify the variables, and if you're not sure which ones, look at the units. Those are going to be your key indicators to tell you. So this is my mass, so I put that mass. This is my velocity, I put that velocity, and then we solve for our third, the unknown. In this case, that's the kinetic energy, and it's equal to 24 joules. So let's go ahead and look at this one now. A 4 kilogram object, so that's giving me a mass. I know that because it's kg. Possesses 18 joules of kinetic energy. So now this is joules, so that's giving me kinetic energy. So what's its velocity? Again, I'm going to go look at the equation. Kinetic energy equals 1/2 mv squared. Okay, then I'm going to plug in what I know. I know that kinetic energy, because this is in joules, I know that energy is in unit of joules. So 18 is equal to 1/2 times the mass. I know the mass right here, that's 4. And then times v squared. So I need to get v squared on its own side right here. So I'm going to take half of 4 to begin with. So that's 18 is then just equal to half of 4 is 2. V squared. Divide, I need to get v squared still on its own. So get rid of this 2, divide both sides by 2. So 18 divided by 2 is 9. 2 divided by 2 is 1. So this just becomes v squared. Now I need to take the square root of v squared because I don't want v squared. I want v. Well, to get rid of v squared, I just take the square root of it. So that's going to give me v. And then if I take the square root to this side, I have to take it to this side. Square root of 9 is 3. So that's going to be equal to velocity here. Now I can't forget my unit. So this is 3 and meters per second because I know velocity right here is always in meters per second. Okay, so same equation we're using here. It just gives me a different unknown. Instead of giving me mass and velocity, it gives me mass and kinetic energy. And I can go ahead and solve for that third variable. Okay, the last one's going to do the same thing. It's just not going to give me the mass. Okay, so we're getting this idea is we can use this equation. We can use it in 3 different ways depending on what they don't give us and then solve for the other 2. So let's just go ahead and read it and identify what we have. An object has 90,000 joules of kinetic energy. Okay, so that's Ke right there. And is moving at a speed of 12 meters per second right here. Okay, what is the object's mass? So again, it's giving me kinetic energy. I know I'm going to use the kinetic energy. I can drag this down here. the kinetic energy equation. So I'm going to go ahead and put that in here. Kinetic energy is equal to 1/2 mv squared. Okay, so I know that 90,000 is equal to 1/2 mass times velocity squared here. Well, the velocity is telling me 12, so this is going to be 12 squared. Okay, so I'm going to go ahead and take care of that square first. So that's 90,000 is equal to 1/2 times the mass. And then 12 times 12 is 144. Down just a little bit here. Okay, then I'm going to take half of 144. That's going to get me 72. So I got 90,000 here. Is then equal to 72 times m. That's the mass I want to go. And I'm going to go ahead and divide both sides by 72 to get mass on its own. If I remember correctly here, I believe this is 1,250 kilograms is what that equals to. Go ahead and check my math. You can go ahead and, again, just take 90,000 divided by 72. We did this early today in class, so I believe, if I'm just going off the top of my head, I think it's 1,250 kilograms. So we've done the kinetic energy 3 different ways. First time we didn't have this, so we just plugged in mass and velocity. The second time we didn't have velocity, so we solved it right here. And now the third time we didn't have mass. And whatever it gives us, we can solve for anyway just doing that. Okay, I'm going to drag down my 2 equations we're using here now. Question 4, a 40 kilogram box is placed on a 2 meter tall shelf. What is the gravitational potential energy? Okay, gravitational potential energy right here, right? So now we're dealing with this equation, the second equation. And it gives me my mass right here, and it gives me my height right here. So I'm going to go ahead and first just set up my equation. PE equals mgh. And I know I'm solving for potential energy, so PE. Now mass right here gives me is 40 kilograms, so I'm going to plug in 40. My G, we always know, is equal to 10. We're rounding here. And then my height right here is equal to 2 meters. So I just have to really just multiply these all together. So 10 times 40, that's going to give me 400. 400 times 2, that gives me 800. So the answer to this is 800 joules. Okay. Pretty straightforward. I think potential energy problems are always a little bit easier than the other ones here. Okay, so let's keep going here. I have this box that's on the shelf, right? It's 2 meters tall, so we're talking a little less than 7 feet tall. It has a mass of 40 kilograms. It's not moving yet, so it just has that potential energy of 800 joules. Well, part B says if the box falls off the shelf, what is its kinetic energy as it strikes the ground? Well, right as it's striking the ground, we know that the height is 0. So if we go ahead, I'm going to rewrite my 2 equations here. So I got kinetic energy is equal to 1/2 mv squared. Now then, let's still know that potential energy is equal to mgh. So what this is saying is, right before it hits the ground, the height right here is 0. Well, we had 800 joules that was potential energy. Well, that's gone away, right? There's no more potential energy as it's hitting the ground because it's at a 0 height. But we also talked about how you can't just get rid of energy. Okay, there's a certain amount of energy in the universe is always there, and we're always going to have it. And so if this had 800 joules, somehow got 800 joules, it has to go somewhere. It can get rid of it. It just has to transfer it to someone else. So what is it going to do? Well, it starts in the air, and it's going to gain speed. So it's going to convert that all to kinetic energy. And it's going to, we know that if it starts with 800 potential, that has to go somewhere. So that's all going to go to 800 joules. So the box off the shelf falls off the shelf with kinetic energy. As it strikes around, it's got to be 800 joules. It has to be the same amount that it started with. So it started with 800 joules here. It has to end with 800 joules here. Remember, we saw this. We did that virtual lab with the skateboard, go up and down a ramp, and it just transfers from kinetic to potential. Same thing here. Now, this isn't going to go back up, but we're seeing that it's all potential, and it goes to kinetic here. Now, this is a really important concept to understand the next part of this. What is the velocity of the box? So I was able to calculate, in that first part, I calculated potential energy. But it's converting all my potential. So it's taking all this potential energy and it's turning it into kinetic here. Well, I know what that kinetic's going to be, right? We just said it's equal to 800. I also know the mass of this box, right? The mass of the box is 40 kilograms. That came right here, 40 kilograms. So I know what the kinetic energy is going to be. That's that 800. I also know the mass. Now we can go ahead and solve for the velocity using my equation right here, and that's what it's asking for. What is the velocity of the box immediately before it strikes the ground? So I go kinetic energy is equal to 1/2 mass times velocity squared. The kinetic energy is equal to 800. 1/2. I know the mass is equal to 40 here, and then v squared. I'm going to go ahead and simplify that one side right there. So half of 40 is 20. And then I got v squared right here. I'm going to divide both sides right here by 20. So I get 800 divided by 20, which that's a lot of zeros. So I'm going to take off 1 0 on the 800 to make that 80. Take off a 0 on the 20, make that 2. So 80 divided by 2 is 40. So my answer here is 40 is equal to v squared. Okay, so I know that talking about perfect roots here, this is 36 is right below it, which is 6, and then I got 49, which is above it. So this is going to be a little more than 6, probably about 6.3, something like that. I think it's somewhere around there, so I'm just going to go right now. Throw this in your calculator, but we're going to give about 6.3 meters per second right here. Okay, just ignore my dog's barks in the background here. So, question right here. 1.5 kilogram ball is thrown upwards with a velocity of 6 meters per second. What's the kinetic energy of the ball being thrown upwards? Okay, so I got my mass right here. I got my velocity right here. What's my kinetic energy? Well, let me drag this equation down so we have our two equations we're working with. So, my kinetic energy is this equation, 1/2 mv squared. Well, I got my mass, I got my velocity. I can go ahead and plug that in there. That's not too big of a deal. So kinetic energy is equal to 1/2 mass times velocity squared. You can go ahead and plug those in here. So 1/2 times my mass of 1.5, and then times my velocity squared. So that's going to be 6 squared. Okay, so I go ahead and let's simplify this here. So let's do, I got 36 here. So 1/2 times 1.5 times 36, that's 6 squared. Put that in parentheses here. Okay, so then we can do either of these first. Let's just take half of 36 first. I think that might be a little bit easier than go with 1.5. So half of 36 is going to be 18. So that's going to be 1.5 times 18. Anytime you do 1.5, right, I can just split that in 1 times 18 plus 0.5 times 18. That's a nice little trick here. So really it's just what's half of 18 plus 18. So in this case, half of 18 is 9. So 18 plus 9 is 27. So 1.5 times 18 is 27 right here. And that's going to be 27. We know we're calculating kinetic energy, so this should be a unit of joules. Okay, so we went ahead and calculated the kinetic energy here. So what is the gravitational potential of the ball as it reaches its highest point? Okay, so let's think about this. I've thrown this ball up. We can calculate how much kinetic energy as it's going up from the initial spot. Well, the ball's moving up, but gravity's pulling it down, right? So what it ends up happening to this ball, it slows it down. It starts with 6 meters per second, but it's going to slow it down, and then it's going to eventually, what do balls do when you throw them up in the air? They come back down. They fall to the ground. Why? Because gravity's pulling them down. So it's going to go up, gravity slowing it down, slowing it down, slowing it down, going up, right? And eventually it's going to come to a stop. And then it's going to accelerate, going downwards so that its velocity increases downward. It accelerates downward the whole time, but it's decreasing its velocity going up, and then it increases its velocity going down. That moment at the top, when it changes its directions, just for that moment, its velocity is 0. So we said its total kinetic to begin with 27, but if its velocity for that moment is 0, the kinetic energy goes away, right? Because velocity, if it's 0, kinetic energy would be 0 because my velocity is 0. So where does it all go? Well, it's all going to go, in this case, to potential energy. So in the one before, we saw potential energy go to kinetic. Now we're seeing kinetic going to potential. So if it's all going to potential, what is the gravitational potential energy of the ball when it reaches its highest point? It has to be what the kinetic was right here, right? Because all of that kinetic is turning into potential. So this should be 27 joules as well. Well, if that's the case, then what height above the thrower's hand will the ball rise? Well, now, if I know that this is going to be 27, I also know the mass is 1.5, right? And then I also know that G is always 10. Where are you always using 10 in here? So then I can go ahead and solve. I know these three. I can just solve for H right here. So I'm going to set up my equation of potential energy is equal to mgh. So I'm going to say 27 is equal to the mass of 1.5 times 10, and then times h. So if I simplify each of my sides here, so I get 27 is equal to 15 times h. I divide 27 by 15, and I believe that comes out to 1.8 meters right there. Double check me there, but I believe I did that correctly. I think it's 1.8. Okay, so now it kind of walks us through. Notice in these two problems, it was a three-step problem. It asks us to calculate one, then it asks us, well, what's it going to turn into? And so that's that natural process of knowing it's going to convert one to another. Then we got two more problems here, and it just kind of is combining that all in one, right? So it's kind of stepping this into this process. So what it's saying right here is we got a 2-kilogram watermelon from a 4-meter tall roof. Okay, how fast will the watermelon be going when it strikes the ground below? Okay, so let's just write our two equations here again. So I got kinetic energy is equal to 1/2 mv squared. Okay, let's fix that there. There we go. And then also my potential energy is equal to mgh. So those are my two equations I'm working with. It wants velocity, so we're going to end up with kinetic. But notice I don't know the kinetic energy and I don't know the velocity. I do not have enough to figure this out. But what I do have is mass and the height. So I do have enough to figure out its initial potential energy. So I'm going to go ahead and start with potential energy in this case. And then when I find potential energy, I know that as that falls, that potential energy is going to turn into kinetic energy. That's just like how we did in the examples of converting one to another. So I'm going to go ahead and solve for the potential energy, set that equal to my kinetic, and then I can do that there, okay? So I just want to give you a heads up. We're going to do a quiz, and the quiz is going to be just this problem. You're going to get different numbers, but I just want to make sure that everyone knows how to do this. So please make sure that this is going to make sense to you. As I go through this, you're going to see this again for your quiz. I'm going to go ahead now and solve for that potential energy. I'm going to put in my equation here. Potential energy is equal to mass times gravity times height. So I have the mass, which is 2 kilograms. Gravity, again, we're just assuming is 10. We always know that here on Earth. And then the height is 4 meters. So I have enough to actually calculate just the potential energy here. So potential energy is equal to 2 times 10 times 4 right there. So this is going to give me a potential energy of, I got 2 times 10, that's 20. 20 times 4, that's going to be 80. And this is potential energy, right? So we know this is going to be in joules. Okay, so this is my potential energy. So this will also equal my kinetic energy, right? So this is on the roof. It wants to know what's its as it falls. Well, as it falls, the height goes to 0. As height goes to 0, there'll be no potential energy. Where does all that go? It turns into kinetic energy. All right, so now I can say my kinetic energy will equal 80 joules at the moment it's hitting the ground. At that exact moment it's hitting the ground, it's going to be 80 joules. So now that I know how much it will be, so KE, again, I'm going to write my equation here. I'm going to mv squared. So I know 80 is equal to 1/2 times my mass, which is just 2 in this case, times velocity squared. Okay, so again, we're just going to simplify these parts here. So I got 80. Well, the nice thing here is half of 2 is just 1, so this one really takes care of itself there. So it's just equal to v squared. Oh, man, that is so close to my perfect square, right? My perfect square would be 81 is the number coming from 9. So 9 is actually my perfect square, and that gives me 81. Right below it, right? So I'm going to go plug this on a calculator, and I'm going to get somewhere. I know it's going to be just right at like 8.9 something. I'm just going to call this 8.9. So the velocity is 8.9. Might have to worry about it rounding up to 9, but I think we're okay with 8.9 meters per second here. Go ahead, double check me here, put this in the calculator, but we get 8.9 meters per second. Okay, and the idea was here is we have enough to potential energy, and it's going to go ahead and convert that right before it hits, right? So as it strikes the ground, meaning the height is 0. So it's lost all this potential. Where is it going? It's going kinetic. Then we can use the kinetic equation. Okay, the last one here, and then we're going to be done. To what height will a 250-gram soccer ball rise if it is kicked directly upward at 8 meters per second? Okay, so it's giving us a velocity here. It's giving us a mass. So we have enough to calculate kinetic energy, right? So we're going to start with KE. But it wants to know the height. Now, height is not part of kinetic energy. Height is part of potential. So we're going to solve for kinetic energy, and then we're going to go ahead and then use that to solve for the height component, the variable, inside of potential energy. So we're using kinetic in this case to know the potential. We just did potential to kinetic. Now we're going to kinetic to potential. The one thing we do have to be careful about here is this is 250 grams, okay? All of our masses are in kilograms. So I need to go ahead and convert this. A couple ways to do this. If you want to do the stair-step method, you can pull out your stair-step case there, and you're going to count the amount of steps go from grams to kilograms, right? And that's kilograms is up 3 steps, so that's going to move it 1, 2, 3. Or you can just know that there's 1,000 grams per kilogram, so you're going to divide by 1,000.25 another way there. But I'm going to go ahead and rewrite this here just so we don't get confused. This is going to be 0.25 kilograms right here. Okay. So now that we've converted our mass to the right unit here, now I'm going to start with my kinetic energy. So kinetic energy is equal to 1/2 mv squared. I can plug in what I know at this point. So that's 1/2 times 0.25 times 8 squared. Okay, I'm going to simplify this first. I'm going to start with 8 squared. I think that's going to be the easiest thing to do. Give me a nice number to work with these with here. So that's still 1/2 times 0.25. And that's going to be times 64. Okay, so now I got 1/2 and a quarter. I think 64 is a nice big number here. So I'm going to do my quarter for it first, right? And a quarter, taking a quarter of something is just 1/2 of a 1/2. So if I just go ahead and half this twice, that's going to give me what I need. So 1/2 of 64 is 32. 1/2 of 32 is 16. So that's going to get me down to get rid of my quarter here. So that's 1/2 times 16. And then I still need to go and take 1/2 of that, right? So 1/2 of 16. My kinetic energy right here is going to be equal to 8 joules. Okay, so that gives me my kinetic energy. And then we just said right here that my kinetic energy is going to go ahead and turn into my potential energy, right? So I'm kicking the soccer ball. It starts with total amount of high velocity. It's going to go straight up. Then at the top of that trajectory, like we talked about before, it's going to stop and then come back down to earth. So at the very top, the velocity is 0, and it's 100% into the potential energy. So I'm going to go ahead and plug this in right here. Potential energy is equal to mgh. So I know that potential energy right here should be equal to 8 joules, or I'm going to just plug in 8. I know the mass is equal to 0.25. I know that gravity is equal to 10. And h is what I'm solving for right here, right? So I'm going to go ahead and simplify this side here. So that's 2.5 times h. I'm going to go ahead then and take 8 divided by 2.5. When I do that, I get... Oh, goodness, I don't remember what this is. So it should be just a little more than 3, right? Because 3 times 2.5 is going to be 7.5. And then with 0.5 left over. So that's going to give me, I don't know, 3.2 or something like that. Double check me, I might be a little off, but I think that's about close enough. And that's 3.2 meters. Okay. And that is our answer right here. So, sorry about the dog barking a few times there, but let's just review here. We get mass, we get velocity, right? That's enough to calculate our kinetic. But I want to know the height that it goes up. So at that very height, the top that it goes up, its velocity will be 0 just for a moment, okay, as it's changing directions in the air. And so since the velocity is 0, all that will, for just a moment, will convert to potential energy. So I can take this 8 joules, set it equal to my potential, and then I can solve for the height right there. Okay. If you have any questions, let me know, but hopefully that makes sense to you, and you'll have a quiz over this here.